Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have solved 4 important problems on NFA construction. And today in this lecture, that is problems on NFA set 2, we are going to solve few more remaining questions on NFA construction based on the length of the string. So let's get started. In this lecture, we will solve total 3 problems on NFA construction. So let's read the very first problem. Design an NFA that accepts all strings with length exactly 2 over the alphabet A, B, which means you are required to construct a non-deterministic finite automata that will accept all the strings made up of A's and B's such that the length of the string is exactly equal to 2. Now, length exactly equal to 2 means that the number of symbols in the strings should be exactly equal to 2. Not less than 2, not greater than 2. Now, what are these 2 symbols in the strings? As you can see, our alphabet is A, B. So, these 2 symbols can be either A or B. So, the first symbol can also be either A or B, and the second symbol will also be either A or B. Let's start designing our NFA. First, we will have our initial state, which is Q0. On getting the first symbol, which can be either A or B, we will reach the state Q1. And on getting the second symbol, which also can be either A or B, we will reach the final state, which is Q2. And now our string is having 2 symbols. That is why the string is getting accepted. So this is the required NFA for this problem. Now, if it was required to create the DFA for the same problem, then we need to add one more transition for the state Q2 for the symbols A and B. That would depict the strings of length greater than 2, which will lead to the dead state. But in case of NFA, we usually focus only on the acceptance path. The path which is not present in NFA will automatically lead to rejection of the string. So let's move towards the second question. Design an NFA that accepts all the strings with length at most 2 over the alphabet A, B. That means you are required to construct an NFA that accepts all the strings made up of A's and B's such that the length of the string is at most 2. Now, length at most 2 means the number of symbols in the strings should be less than or equal to 2. The number of the symbols in the strings should not be greater than 2. So let's start designing our NFA. First, we will have our initial state, which is Q0. And you can see Q0 is the final state also. Why? Because as per this question, the length of the string should be at most 2. So the length of the string can be 0, length of the string can be 1, and length of the string can be 2. If the length of the string is 0, that means there is no symbol in the string. And here you can see if there is no symbol in the string, that will also be accepted because 0 is also less than 2. If I get only one symbol from A or B, that will also be accepted because 1 is also less than 2. If I get one more symbol, either A or B, that will also be accepted because 2 is also less than equal to 2. But if I get one more symbol, that will be rejected, and we need not to show the rejection path in case of NFA. So this is the complete, required and valid NFA for this problem. Now let's proceed to our last problem. Design an NFA that accepts all the strings with length at least 2 over the alphabet A, B, which means you are required to construct an NFA that will accept all the strings made up of A's and B's such that the length of the string is at least 2. Length at least 2 means that the number of symbols in the strings should be greater than equal to 2. The number of symbols in the string should not be less than 2. Let's start designing our NFA. First, we will have our initial state, which is Q0. If I get only one symbol, our string is not getting accepted. It is reaching an intermediate state, which is Q1. But if I get one more symbol, the number of symbols are 2. That means our string will be accepted because as per the question, the number of symbols should be greater than or equal to 2. So if we get more symbols after getting the second symbol, that will also be accepted because number of symbols can be greater than 2. So we will simply create a self loop over the state Q2 for the symbols A and B, which depict that there can be more than 2 symbols in the string, which will be accepted. So these were the 3 important problems based on NFA construction that required the knowledge of length of the string. Now, before ending this lecture, I have one homework problem for you. So here is the homework problem. In this problem, you are required to select the correct NFA out of these 4 NFA that accepts all the strings over the alphabet 0, 1 such that the third symbol from the right end of the string is 0. So solve this problem, and once you find the correct option, do not forget to post it in the comment section. So in this way, we have completed our topic, problems on NFA. So till now, we have completed 2 major topics of theory of computation, the deterministic finite automata and the non-deterministic finite automata. From the next lecture onwards, we are going to start with one of the most important topics of TOC, that is repeatedly asked in your examinations, conversion of NFA into DFA. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.